Hello, this is the video for Chapter 9, Lesson 2. So in this lesson, we are going to tackle two big topics, and these might sound familiar to you. The first one is prime numbers, and the second one is composite numbers. So these are actually two opposite things, and I'll let you think a little bit. What is a prime number? Well, if I were you, I would take out your notes and write down a few things here, kind of like what I've written. A prime number, let's write down the definition. It is a whole number that can only be divided by one in itself, or can only be factored by one in itself. I'm going to say the word factor because that's going to be a word we're going to use a lot, but that means divided, right? Can only be factored by one and itself. And you know what? I think I might type the rest out here. A composite number is the opposite. It's a whole number that can be divided by more than just one thing and itself. So some examples of prime numbers would be like 2. 2 can only be divided by 1 in itself. 3, 5, 7, 11, 13. And if you want to go ahead and Google like a picture of prime numbers, you'll see a whole list, of prime numbers where these are a list of numbers that can only be divided by one itself. Composite numbers would be examples like any even numbers except for 2. Why do you think any even number would be a composite number? Well, because any even number can be divided by 2, right? So that would be 1 itself, the number itself, and then 2, which would be being divided by more than 1 in itself. So let's kind of take a look here. We've got a list of numbers. Is it prime or composite? So I give you a second, and maybe you could write down these numbers on your paper and think through, are these prime numbers or composite numbers? You can pause the video and kind of copy this down. And then I will now give you the answer. So 27, that's divisible by 3 and 9. So this is a composite number. 151, there's not a number that I can think of that goes into 151. So that's prime. 77, that can be divided by 11 or 7. So composite. 25 can be divided by 5. So composite. 92 is an even number that must be able to be divided by 2. So composite. 49, divisible by 7. Composite. 101, I can't think of one. This is a prime. 81, divisible by 9. So composite. So there's your answers there. Is it prime or composite? We can kind of take a look. And if you can think of any number besides 1 in itself that can be divided evenly into it, then it's composite. Let's talk about the factor tree. So this will be very useful as we continue to take a look at composite numbers. So an example of a number like 27. If I want to break down 27 into multiples of basically of its prime numbers, what I can do is create a factor tree. So basically what I'm going to do is I'm going to look at this number, then I'm going to branch it off into the products, a pair of products that make 27. So for example, 3 and 9. 3 and 9, when you multiply them, make 27. Well, my recommendation to you is when you get to a prime, circle it. That means you can't branch that number off anymore. However, if it's not a prime number, that means you can branch it off some more. So 9 can be broken into 3 and 3. And so in this case, 27 can be broken down into 3 times 3 times 3. And if you were to get your calculator out and plug this in, 3 times 3 times 3 is 27. So we're breaking 27 down into all primes. Let's take a look at 92. Oops, don't know what's going on there. 92. So this one, I'll do it over here. 92, I'm gonna break it down. Okay, 92, I know for sure it's divisible by 2. So 92 divided by 2 is 46. Okay, this is a prime. I'm going to circle it. Then I'm going to break down 46. Can 46 be broken down anymore? Well, it's an even number, so I know 2 is divisible, which means I'm going to break it down. 2 times what is 46? Well, I think 23. Okay, so 2 times 23. Now, 23 is a prime number, so I really can't break that down anymore, which means if I'm breaking down 92, the factors, so there's the word factor, the factors of 92 are 2 times 2 times 23. Let's take a look at 81. We'll do one more. So 81, we'll break it down. 9 times 9 makes it 81. Now, both of these are not prime. So I'm going to break both of the 9s down. 9 is divisible by 3, which is 3 times 3, right? And these are prime, so I'm going to circle them. 3 times 3, which means 81 can be rewritten as 3 times 3 times 3 times 3. And if you plug that in, you should be able to check your answer and get 81. So I know that on facts, you're missing the first page of your study guide. That's basically what all this is going over. So if you want to go back and take notes if you haven't, record some of this stuff, do a few factor trees for practice. We're also going to do some factor trees here. So this is page 2 of the study guide. What we're going to do is we are going to break a monomial down into factors. So a monomial is really just any term that is a number itself, a variable itself, or a number times a variable. A not monomial is when there is like an operation in between the terms, so like an addition sign in between 38 and 5, or subtraction sign between 4 minus x. So these are non-monomials because of the addition or subtraction operation that's separating the terms. These are examples of monomials, even with exponents, as long as there's no addition or subtraction in between these terms, these are all considered monomials. So what we're going to do is we're going to break our monomials down into just prime numbers. So we probably want to get some scratch paper and do some factor trees. For number 1, 21 can be broken down to 3 and 7. Both of these are primes. So to factor 21 times t, it would be 3 times 7 times t. Skipped ahead. 3 times 7 times t. And when we break it down, we want to write our numbers first, usually from least to greatest, and then our variables at the end. Okay, number 3, let's just go down and do these odds, okay? So number 3, we've got a negative number. Anytime you have a negative number, we're going to factor out the -1 before we break down the rest of the numbers. So 45 can be broken down to 5 and 9. 9 can be broken down to 3 and 3. So I'm going to start with my smaller numbers first. 3 times 5 times c squared. So it's going to be c times c. Number 5, 6 can be broken down. That one I don't think I need to make a factor tree. It's just 2 times 3. And then times m times m times m. So times m 3 times. Number 7, there's no coefficients, no numbers in front of the variable. So I'm just going to break this down as a times b times b times c 3 times. Let me actually make this a little bit bigger so we can see it a little bit better. Number 9, there's a negative. I'm going to put that negative in front and then break down the 6. 6, I've already broken down earlier, is 2 times 3. Then I have f times f times f times g times g times g. I hope you're getting the idea here. 81, I think I'm gonna, or 80, sorry, 80, I'm gonna break down 8 and 10. These are both composite numbers. So 2 and 4 here, and then 2 and 5. 4 can be broken down some more, so I have actually 2 and 2, 2, 2 and 5. So 4 2s and 1 5. -1 times 2 times 2 times 2 times 2 times 5 times s 4 times t 2 times. Okay, I'm going to skip down to 15. 15, 35, 7 and 5, those are already primes. So this is going to be -1 times 5 times 7. And then times x 3 times and y 3 times. There you go. Hopefully this isn't too overwhelming for you. That's all we're looking at today. It's just breaking down monomial into all prime numbers by, if we need to, using the factor tree, and breaking down any exponents into the basic form of that variable. All right, that's all that I have.